Okay, let's look at the homework 13, problem number 7. Right? So we want to find the volume in the first octant, which means that the x is positive, y is positive, z is positive, by the paraboloid z equals 1 minus x squared minus y squared, which it looks like a bullet, just facing upward. And the plane x plus y equals 1, and all three coordinate planes. So this is what it looks like. Let's draw a picture. All right, so it's a paraboloid. It's going to go through 1 here on z-axis, and you have a parabola. Looks like kind of like this, and it's going to look like a parabola here. All right, then you're cutting by a plane, the x plus y equals 1, which looks like this. So it's connecting, so it's going to be a straight line here. So that cuts the xy plane like this. And then you have a plane, so it's just a plane, looks like this. Right, so I'm just drawing the plane like this. Right, then the paraboloid is cut, and I think the cross section looks somewhat like, oops, sorry, cross section is somewhat like this. All right, so like a bullet shape, it's cut by xz plane, yz plane, and xy plane, and also this plane, x plus y equals 1. Right, so the bullet shape is looks like this. So here's the bullet shape going on. So this is the solid that we're looking at, and you have flat cross section here. Right, so that's the solid that we're looking at. Right, so we need to look at the area region on the xy axis so that we can integrate over that region, and I'm gonna shade that region here. So the region in the xy plane, so this is the region right here. It's actually just a triangular region. Right, so you have a triangular region. And if we want, we can actually sketch the picture of the xy plane, the region in the xy plane. So it looks like this. So here, draw the x-axis. Oops, I'll probably want to draw with the black, right, like that, and a y-axis. Like that. Then you have let's see, so here's the y-axis, origin, and x, right, and y equal x plus y equals 1 looks like this. So here's 1 here, and here's 1 here. Right, then just a straight line through those both points there. Right, then this is the region right here. Right, that's the region we're talking about. All right, so we can set up an integral this way. So the volume is going to be v is equal to, right, I'm going to use a double integral, so here's a double integral here. All right, then looks like the height is determined by this paraboloid, so it's going to be 1 minus x squared minus y squared. Right, then we can do it either way, but maybe I should do let's fix the x value. Right, so for a fixed x value right here, right, y is going to go from this point all the way to the line there. So that line, the equation is x plus y equals 1, but we can solve for y, so y equals 1 minus x, right? So let's do the integral with respect to y first, then do with respect to x, right? So y is going to go from, right, here is 0, y equals 0, all the way up to this line, which is y equals negative 1 minus x, right? Then to cover the entire region, x has to go from 0, which gives you that, and all the way to x equals 1. So we know that the x is going to go from 0 to 1, right? So this will give you the volume of this solid right here, and let you evaluate this integral. Right? That's it. I hope that this will get you going.